In this video, we're going to look at applications of multiplying matrices with a couple of examples. Our first example has a shop that sells apple, cherry and blueberry pies for $3, $4 and $2 each. We can write this information as a row matrix. I'm going to call the matrix matrix C because it's the cost of the pies. And in kids, we've got apple pies for $3, cherry pies for $4 and blueberry pies for $2 each. The other information I've been given is the number of pies sold over a period of 4 days. So my rows are the types of pies and my columns are the days. The question that has been asked is, what is the total value of sales for each day? So I need not the total number of pies sold, but the value of the pies sold. I'm going to write this second part of information as a matrix. This is going to be called matrix N for the number. And you can see I've got each of my rows tells me the type of pies and each of my columns tells me the days they were sold on. So what I need to do is I need to multiply the value of each pie by the number of pies sold. So I'm going to multiply my matrix C with my matrix N. Now matrix C is a 1 by 3 matrix and matrix N is a 3 by 4 matrix, so I can multiply them together. And if we look what's happening, we're multiplying the price of each pie with the number of pies sold. So what we'll do is the $3 for each apple pie will be multiplied by the 13 pies sold, $4 for cherry pies by 8 pies sold, and so on. Let's have a look at how this works. The resultant matrix, because I have a 1 by 3 and a 3 by 4, they're the same, is going to be a 1 by 4 matrix. And I'm just going to label my values with my pronumerals A, B, C, and D. So let's have a look at this in practice. So that I know that on Monday, 13 apple pies were sold, 8 cherry pies, and 6 blueberry pies were sold. So it's going to be $3 by 13, $4 by 8, and 2 by 6. My final matrix, A, is in position row 1, column 1. So that's exactly what I'm doing. I'm multiplying each element in row 1 by each element in column 1. And that gives me $83. 3 by 13, 4 by 8, 2 by 6. On Tuesday, same again. I'm going to need to multiply that by each value in the second column. And if we look at our value for Tuesday's sales, it's in first row, second column. So I'm multiplying the first row with the second column, and that's going to give me the sales for Tuesday. Same again for Wednesday. Wednesday's first row, third column, so I'm multiplying my cost or my value of each pie with the number of pies sold on Wednesday, and same again for Thursday. So this gives me my total sales, so that on Monday the total value of the sales was $83, Tuesday $63, Wednesday $37, Thursday $75. This next example also looks at sales of bakery goods of pies, cakes and breads, but this time it's for 4 different bakeries, bakery A, B, C and D. The question in this one is a little bit different though. It's asking what are the sale amounts for each item in each store. So we're not asking for total sales, we're asking for the value of sales of pies for bakery A, of cakes for bakery A, bread for bakery A, pies for bakery B, and so on. Basically, I'm going to create a matrix to show the sale value of each item for each bakery. Before I can do that, I need some understanding of what an identity matrix is. Now, an identity matrix is a square matrix with one going diagonally from the top left corner to the bottom, and all of the other elements are 0. Now, multiplying a matrix by the identity matrix will not change the original matrix. So let's have a look at what happens. So here is my matrix, and I want to multiply it by the identity matrix. Before I can do that, I need to check my matrix size. My original matrix is a 4 by 3 matrix. So remember, the number of columns in my first matrix needs to equal the number of rows in my second matrix. So I need to multiply it by a 3 by 3 matrix. An identity matrix is always a square matrix. Now, if I multiply my original matrix by my identity matrix, I get the same original matrix. But we can tweak this to make this more useful for us. So let's first of all have a look at how this is going to work. When I'm multiplying my first row by my first column, the 24 is multiplied by the 1, but 5 and 30 are multiplied by 0, which is going to give them 0. So it's really only the 1 that is affecting the things in that the elements in that first column. Same again when I'm looking at my second row. When I multiply my second row by my first column, the 30 is multiplied by the 1, and the 10 and 22 are multiplied by the 0. The same occurs when I'm multiplying by my second column. So if I'm multiplying my first row by my second column, the 24 and the 30 are multiplied by the 0, and it's only the 5 that's going to be multiplied by the 1. This is why it stays the same. Same again when I'm multiplying by my third column. The first two values will be multiplied by 0 in each row, and only the 18 or the 28 or the 22 or the 30 will be multiplied by 1. So this 1 is only going to affect the column that it's in. So the first one will multiply the first column, the second one will multiply the second column, and the third one will multiply the values in the third column. But we don't want these values to be multiplied by 1. We want the values in our first column, our pies, to be multiplied by $6.50. The values in our second column, which are our cakes, to be multiplied by $14. And the number of loaves of bread, our third column, multiplied by $4.50. So what I can do is I can exchange each one of my ones for the value I wanted to be multiplied by. So now 6.5 is going to be multiplied by 24. Now, this is our resultant matrix. We can check this. $156, which is in column 1, row 1, means I've multiplied row 1 by column 1. So therefore, when I'm doing it, only the 24 is multiplied by the $6.50, and the number of cakes and bread are multiplied by 0 to give us our $156. If I look at the $70, which is the value of cakes sold in Bakery A, that's in row 1, column 2. So it means I'm going to be multiplying row 1 with column 2. And you can see now that the 24 and the 30, the number of pies and bread, are multiplied by 0, and only the 5 is multiplied by the $14 to give us our $70. Let's have a look at a value in our third column. This time we're going to look at the value of bread sold in Bakery B. That came to $99. But that's in row 2, column 3, which means we're going to be multiplying row 2 by column 3. And you can see that the number of pies and cakes are multiplied by 0, and it's only the 22 loaves of bread that's multiplied by the $4.50 to give us our $99. In summary, what this means that the value that we've put in our first part of our identity matrix multiplies by the values in our first column. The $14, which is in our second column of our matrix, gets multiplied by the values in the second column of our original matrix. And the $4.50 multiplies by the values in our third column to give us our resultant matrix of the value of each of the pies, cakes and bread for each of the bakeries A, B, C and D.